So, ladies and gentlemen, yesterday we learned pre-notes on the quadratic formula. That was all about simplifying square roots. We talked about perfect square numbers. We practiced simplifying square roots. We even talked about taking the square root of a negative number, which produces an imaginary value. Let's move on to today's notes, the actual notes. The actual notes are right here. And this is supposed to be a class opener. However, I do want to save some time. All I want you to do is remember to find the x and the y intercepts. To find the x-intercept, you set y equal to 0 and solve. So if we were to do that on this y equals 2x minus 4 equation, that would be a 0 equals 2x minus 4. And of course, you would solve that by adding 4. You'd have 4 equals 2x. And you'd get rid of the 2 by dividing by 2. Dividing by 2, x equals 2. That's the x-intercept. We just found the x-intercept, which is telling us that it's going to cross the x-axis at the x value of 2. So if you wanted to write that location as an actual coordinate, you would write your coordinate 2, 0. And that makes total sense because we did set y equal to 0, so the y value has to be 0, which means that when we plugged it in and found out that the x value is 2, that's the x value of our location, so 2, 0. If you wanted to find the y-intercept, you would set x equal to 0 and solve. So for the y-intercept, you would set x equal to 0 and solve. So you would have y equals 2 times 0 minus 4. That'd be 0 minus 4, which means y equals negative 4. That's your y-intercept. That tells you that it crosses your y-axis at negative 4 down here, which means your line would be going right through those two dots. But the point is, the location, the coordinate, would be 0 for the x, negative 4 for the y. That's the location of the y-intercept. Anyways, that's just a review. We also had to simplify these following radical values. We did enough of that yesterday. I'm just going to move on. But I do want to let you know that technically you could do this on the calculator. Yeah, you could do it on the calculator. Look, there's a square root button right there. And if you type in your number into that square root button, like I did up here, 108, it'll give you the simplified square root value, 6 squared root of 3. Okay, 6 squared root of 3. Now, I mean, what did we do yesterday? Yesterday we would say, okay, think of the highest perfect square number that you could use with multiplication to rewrite 108 as one of those. So that'd be like 36 times 3 if you started going through all the different multiples and the perfect square numbers. And then you would split it, and that would give you 6 squared root of 3. But yes, you could use this button, type it into the calculator, and it'll simplify it for you. Now, if you wanted the actual decimal, that crazy irrational decimal value, you could hit the SD button, and that'll change it from this form to a decimal form. Anyway, we want to leave them in simplified form. If you have one of these Casio calculators, it could do that for you. If you don't, then you have to rely on the skills that we learned yesterday. Let's move on to the rest of this and jump right in. We also learned yesterday that all these words mean the same thing when it comes to parabolas, when it comes to quadratic equations and functions. So if I give you a quadratic equation and I tell you to find the answers, it's the same thing as me telling you to solve it, or the same thing as me telling you to find the x-intercepts, or me telling you to find the roots or the zeros, right? So let's say, on this whole left side of the worksheet, it says, so when they ask you to find the x-intercepts, you solve it. When they ask you to find the roots, you solve it. When they ask you to find the answers, you solve it. When they ask you to find the solutions, you solve it. It's all the same thing. So let's say I wanted to solve this first one because they want us to find the x-intercepts. And how do we find the x-intercepts? You set y equal to 0 and solve. So you would have 0 equals x squared plus 4x plus 3. But instead of having equal 0 on the left side, you could put equal 0 on the right side. And then from there, you could think, well, this is a quadratic trinomial. The a value is 1, so maybe I could factor it, and then I could split it and solve it, right? Because when there's no number in the front, x times x will give you the x squared. And what was the thought process on factoring standard form quadratic trinomials when the a value is 1? All you do is think, what times what is c, that if you combine together is b? And that would be a 1 times 3. 1 times 3, and it doesn't matter what order you put it in. You can put a 3 first and a 1 second. 3 times 1 is 3, and if you add 3 and 1 together, it will give you the middle value 4. So this is the correct factored form, and you could then split it and say that x plus 3 could be 0 and x plus 1 could be 0. That's called using the zero product property, that when you have something times something that equals 0, the first something could be 0 and the second something could be 0. Produces two simple equations, which gives you two simple answers. X equals -3 and x equals -1. That one came out ugly. There you go. Now, was that difficult? No. Is there an easier way to do it? Yeah. Yeah. You could go to Desmos and you could type it in, and voila, you're going to be able to identify where it crosses the x-axis. So it crosses at -3 and a positive and at -1. So that means that my answers are -3 and -1. So sometimes, you could factor, especially when you don't have Desmos or you don't have a graphing calculator. Go ahead and factor, split, and solve. But if you have Desmos, which all of you do have on the Google, on your Chromebooks, you could just graph it and see what the answers are. Now, on quadratics that produce parabolas, most of the time you're going to get two answers, right? But not all the time, okay? So instead of going through all these and trying to factor, split, and solve, if you use Desmos, like on this one especially, like let's say you did try to factor it, x, and you're thinking, what times what is 4 that if I add together is -2? Well, what times what is 4? It's 1 times 4 or 2 times 2. And if I add these together, it gives me 5, not -2. If I add these together, it gives me 4, not -2. What does that mean? This is not factorable. It's not factorable, which means that it doesn't have real answers. And what does that mean? That if you were to graph it on Desmos and you're looking for the x-intercepts, which are your solutions, you're going to see that it doesn't cross the x-axis. So that's why there's no real solutions to that problem. Okay, so you could graph every single quadratic equation that they ask you to solve, and if you're able to find your x-intercepts, like right here, I graphed this guy right here. I took the x squared minus 7x minus 18. I graphed it. I got -2 as an answer and 9 as an answer. Well, x-intercepts and x-intercepts are answers. So I would know right off the bat that my answer is x equals -2 and x equals +9. That means that...
Trying to find the x-intercept?
Well, that means that no matter what they ask you, whether they're asking you for answers, solutions, x-intercepts, roots, zeros, they all mean the same thing. So if you graph them all and you find the x-intercepts, then you're technically finding the answers, the roots, the solutions, the zeros, right? So you could use graphing. Now, the problem is when you graph something that doesn't cross the x-axis, then there's no real solution, but there technically is an imaginary solution, but we'll get to that later, okay? Right now, what I would like you guys to do is take a look at this one up here. It says, what if they ask you to solve something that's simply not factorable? Like this one. It says, how do you solve it? Where if you started thinking, well, I want to try to factor it, and you think, what times what is -6 at? If you add together is -7, it doesn't work. So how do you solve it? The bottom line is the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a, that will always work on any quadratic equation, regardless of whether it crosses the x-axis or not. The quadratic formula will produce answers, or produce an answer or answers. It might even produce imaginary answers, but the quadratic formula always works. So if we were to graph this guy on Desmos, we would see that it does cross at two locations, but they're not nice answers. They're crazy decimals, -0.772, and technically that continues forever, but they just round it off right there. So you obviously don't want to write a crazy decimal as an answer. We're going to use a quadratic formula. And let me show you how to use the quadratic formula on this question. First, you got to memorize it. Negative b plus or minus square root of b squared minus 4ac all divided by 2 times a. And when you use the formula, I recommend writing it with parentheses. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. If you're thinking, wait a minute, I don't have that memorized yet. Okay, well, go ahead and look at it up here and rewrite it. But as you're writing it, replace the b with parentheses, negative parentheses, plus or minus square root of parentheses squared minus 4 times parentheses, all divided by 2 times parentheses. You want to do that every single time you use a quadratic formula. You want to write it like this. That way you don't make mistakes. After rewriting it with parentheses, then you identify your a value, which technically is a 1, the b value, which is negative 7, and the c value, which is negative 6, and then plug them in. So the formula starts out negative b, so that is a negative 7. And there's also a b squared inside the square root. That's a negative 7 inside the square root. Squared, of course. And then minus 4 times a times c. Well, the a value is 1, so you put a 1 right there and a 1 down there. And the c value is negative 6, so you put a negative 6 right there. And this is applying the quadratic formula, okay? Now, how do I start simplifying this formula? You start with the discriminant value. And if you're thinking, what the heck? What did you say? I said discriminant. And the discriminant is a special vocab word that describes b squared minus 4 times a times c. The inside of the square root, that's what we call the discriminant. Yeah, we got to simplify that discriminant first. So when you're looking at the inside of the square root, what I highlighted in red right there, you start with the exponent, negative 7 squared. Negative 7 times itself is a positive 49. And then you move on to the rest. You could multiply 4 times 1 times negative 6 and then subtract that value, or you could make that minus sign as a negative sign and consider it a negative 4 times 1, which would be a negative 4, times negative 6, which would be a positive 24. So inside our square root, I really have a 49 plus 24. Or let me use the vocab word that I just said. The discriminant is 49 plus 24, which would be 73, correct? So what I have here is, instead of a negative 7, I have a positive 7 plus or minus the square root of 73, all divided by 2 times 1, which is 2. Now, normally, you're supposed to, right here we look at 73 and we try to break it down with multiplication to get a perfect square number, just like we did yesterday. Or you could type it into the Casio calculator, and you're going to see that the square root of 73, you can't break it down. So it would stay like that, okay? Let me just verify that again. On the calculator, the square root of 73, yep, is exactly the square root of 73. So you can't simplify that any further. Now, this is the answer. X equals this stuff, and that's technically 2 answers, okay? That's what you write down. That's your answer. That's 100% correct. That's it. But let me just show you that if you wanted the actual, numeric approximations, you would have to write 2 situations, 7 plus the square root of 73 over 2, and also 7 minus the square root of 73 over 2. That's what the plus or minus actually means, that you're going to do 7 plus the square root of 73 divided by 2, and then you're going to do 7 minus the square root of 73 divided by 2. Now, we all know that on the calculator, the square root of 73, since it doesn't work out, that's a crazy decimal number. It's actually 8.544037445, and it continues forever. I just looked at it on the calculator right now. So if I went 7 plus that crazy decimal divided by 2, it's going to give me a crazy decimal. 7 minus that crazy decimal divided by 2, it's going to give me a different crazy decimal. And guess what those crazy decimals are going to be? They're going to be these crazy decimal values that are the x-intercepts. Cool? But when we're writing our answers on quadratic formulas, we want to leave them in radical form. So you want to leave it like this: x equals 7 plus or minus the square root of 73 over 2. So there's a lot to do in this section. Right now, what I would like you to do on these next three equations, there's 1, 2, 3, I would like you to just open up Desmos and practice. Graph these three and tell me what the answers would be, what the x-intercepts would be, the solutions, the roots, whatever you want to call them. Graph them on Desmos and then tell me what to write right here. X equals what and x equals what? That's assuming that it actually has two x-intercepts, right? Go ahead and do that. I want to pause it and then I'll continue right now. So on this first one, you guys just mentioned that the answer is -1 and -3, right? Yeah. Now I could have graphed this by hand by finding the vertex x equals -b over 2 times a, and then plugging in that x value into the x's to find out what my y value is. That's my vertex. The a value is 1. The pattern's 1, 1, 2, 4, 3, 9 from that vertex value, right? But it's a lot easier to just graph it on Desmos. So here it is on Desmos. I typed it in. Here's my parabola. It crosses at -1 and at +3. Okay, so you guys said -3 or +3? -3. Okay, so it's supposed to be -1 and +3. So just by graphing it on Desmos, you will see that the answers are -1, +3. Those are the answers. So that should have been a +3 right there. Okay. If you graph, for the sake of time, I'm just gonna show you the graphs of these next two. So we have those next two problems right there already graphed on Desmos. So yeah, the a value is -1. It has a pattern 1, 1, 2, 4, 3, 9 opening down. The vertex is at -1, 0. And if I'm thinking about the solutions, I'm trying to find the x-intercepts, and this only has one single x-intercept. So the answer here would be x equals -1. Okay. So it's important to note that there's only one answer on this one, x equals -1. Or the x-intercept is at -1, 0, or the roots are just one root, -1, or the zero is just -1. Anyway, that last one, when you graph it, you'll see that it does not cross the x-axis. So that means that there is no solution, no real solution. So you would say no real answer. No real solution. No real x-intercept, no real solution. But when you apply the quadratic formula, in those cases, you're going to be able to find an imaginary solution. Okay. Now, what does this all mean, technically, is when you're using your quadratic formula, as we did on this question right here, the discriminant, if that discriminant is any positive number, doesn't matter if it's a perfect square number or an ugly number like this. If it's a positive number, you're going to end up with two answers. As we saw, it has two x-intercepts, correct? Now, check this out. What if my discriminant, what if that inside value, when I do all this math, the b squared minus 4ac, what if I end up with 0 in there? Well, then it would be the square root of 0, right? And if I had the square root of 0 instead of the square root of 73, what is the square root of 0? Just imagine that. What's the square root of 0?
0.
And if I did 7 plus 0, what would I get? 7. And if I went back down here and I did 7 minus 0, what would I get? 7. So you don't get two answers when your discriminant is 0. You get the same answer, which is just one answer, which means one x-intercept. Does that make sense? Yeah? Now, what if when I did the discriminant instead of 73, what if when I did this discriminant, I got like -4? Well, then when I do the square root of -4, that's imaginary. That means that there's no real answers. That would mean that there's no real x-intercept. So if I compare or if I take that thought process with the three parabolas that I just graphed right here, if I were to use the quadratic formula on this guy, where my a value's 1, my b value's -2, c value's -3. If I use a quadratic formula there, I'll get two answers because the discriminant must be positive for it to give me two answers. But if I did the quadratic formula on this guy, the discriminant must be 0. Because when I do the square root of 0, it's going to give me 0, and it doesn't matter if I add or subtract 0, it's not going to produce two answers. It's only going to produce one answer. And on this guy, the discriminant, if I did b squared minus 4ac, that must give me a negative discriminant value. Why? Because that negative discriminant value will give me an imaginary value, which means that there are no real answers. That means that there are no real x-intercepts. I know this might be a little too much for you, but you could read it down here. it says the value b squared minus 4ac inside the square root of the quadratic formula is called the discriminant. And its value will allow you to see how many answers you'll have, how many solutions you'll have, how many x-intercepts you'll have. If the inside of the square root is greater than 0, if it's positive, it doesn't matter if it's a positive 9 or a positive 37, if your b squared minus 4ac, if your value inside the square root is positive, you're going to get 2 answers. They might be crazy decimals, but they're going to be real solutions. You're going to have 2 x-intercepts. If your discriminant is equal to 0, and then you do the square root of 0, it's going to be 0, and it doesn't matter if you add or subtract 0, you're only going to produce 1 answer, which means that if your discriminant is 0, you're only going to have 1 real intercept, 1 real solution. That means that the parabola only touches the x-axis at 1 location. If your discriminant is less than 0, if it's negative, then you know you have no real solutions. It doesn't cross the x-axis. Why? Because if the discriminant's negative, that means you get imaginary answers. Okay? So we're going to be practicing the quadratic formula a lot, especially tomorrow. Today we're just going through the notes. Tomorrow we're going to practice. But when you're applying the quadratic formula, like we did right here, when we get to this part of our answer, sometimes you could continue simplifying. Sometimes, if you have like the square root of 20, you could rewrite the square root of 20 as 4 times 5 and then rewrite that as 2 square root of 5. And then after that, you might be able to continue simplifying. So I want to practice the last step of our quadratic formula by looking at these 3 examples right here. So when you do the quadratic formula, negative b plus or minus square root of b squared minus 4ac divided by 2 times a, on the inside of the square root, you have b squared minus 4ac. And if you do all that and simplify it, you're going to end up with something like this. But the question is, what do you do from here? Since it's a fraction and you have 1, 2, 3 terms and they're all divisible by 2, you actually reduce it by dividing all of them by 2. So right here, I would divide this by 2 and it'll give me a negative 3. This by 2, it'll give me a 2. This by 2, and it'll give me a 2. So my final step on the quadratic formula, if I actually got here on the quadratic formula, would be to divide everything by 2, and my final answer would be negative 3 plus or minus 2 square root of 3 over 2. Most students do all that hard work on the quadratic formula, and they get to this final part, and they don't do this final step, and they can't find it on the multiple choice, and they get it wrong. Sad, right? So before even practicing the quadratic formula, I want you guys to practice reducing this fraction.
Oh, it's going to be...
You're going to reduce by what?
How
about, since I'm recording, tell me what to reduce by.
It's going to be by 3.
You could reduce by 3, but what's even better to reduce by? By 6, right? So if I go through and 12 divided by 6, that could be a negative 2. 6 divided by 6, 1. 6 divided by 6, 1, right? So my final answer is going to be negative 2 plus or minus the square root of 3, or you could put 1 square root of 3 over 1, but see, the 1s are technically unnecessary. When you have something divided by 1, it's going to be that same something, so don't write the divide by 1. And when you have 1 times something, it's going to be that same something. You don't need the 1, so the simplest answer, or the multiple choice answer that you should be looking for, is negative 2 plus or minus the square root of 3, and that's it. How about this last one right here? What would be, like, let's say I did do the quadratic formula, I simplified everything, and I'm right here on my final step. What's my final answer going to be?
It's going to be negative 4 plus or minus 1.
Negative 4 plus or minus square root of 3 over 2. Now if you're thinking, what the heck, how did you get that? Well, I look at my 3 terms, and they're all divisible by what? By 2. So 8 divided by 2 is 4 with the negative in the front. 2 divided by 2 is 1, which is unnecessary to write in front. 1 times square root of 3 is just going to be square root of 3. And 4 divided by 2 is 2. So that's how we get this final answer. So on the worksheet, we're going to be practicing using the quadratic formula. So on every single one of these, what I would like you to do is write down the quadratic formula, and then from there, rewrite the quadratic formula, but with parentheses, and then identify your A value, which is 1, your B value, which is 2, and your C value, which is negative 3. and then plug in your B values. Your B values are 2 right there and right there. Plug in your A value of 1, which is right there and right there, and your C value of -3, which is right there. And then from there, you work on your, starts with a D, vocab word that I showed you today, discriminant, right? Discriminant, the inside value of the square root. I would start with the square. 2 squared is what? 4. Okay, so I have a 4, and then -4 times 1, let's say -4 times 1, that's -4. And then -4 times -3 is a positive 12. Once again, if you call this a -4 instead of a -4, -4 times 1, that's -4, times -3, that's a positive 12. So my discriminant value is actually 16. So what I have here is -2 plus or minus the square root of 16 over 2. What is the square root of 16? 4. So you have -2 plus or minus 4 square root of 2. And this produces 2 answers. -2 plus 4 over 2 and -2 minus 4 over 2. So up on top, -2 plus 4, that's 2 over 2, which is equal to 1. -2 minus 4, that's -6 over 2, that's equal to -3. So your 2 answers for this problem are x equals 1 and x equals -3. What does that mean? If you were to graph this on Desmos, your parabola would be opening up with the pattern 1, 1, 2, 4, 3, 9, and it would cross the x-axis at 1 and also at -3. We'll pick it up here tomorrow.